Let's do a practical application using the law of cosines. Here's my scenario. I've got a plane. I'm going to specifically have a Cessna 150. They don't go very fast. They go about 110 miles an hour. Now that's in still air. I'm going to start in Denver and go to Kansas City. Which is about 500 miles. Now I'm making that up. It's close, but not perfect. I would need a map and some measuring devices to figure that out for sure. The other thing is, I'm going to say that the navigation numbers or the compass values from Denver to Kansas City are 70 degrees. Again, I'm imagining that it's probably not exactly that. And there's a wind. There is a north wind at 25 miles an hour the whole way. So we've got to deal with that. Now here's a picture of our scenario. So here we've got Denver right here, and here's a compass rose. I need to go to Kansas City, so Kansas City is like over here, and I know from my word problem here that this is 500 miles. Now I also know that there's a south or a north wind, so it's coming this way. So it's going to push my plane to the south. So I'm going to have to steer to the north or aim the plane to the north like this, and then have this. So here's the actual way that we aim the plane, and that's a straight line. Okay. Here's the result. This is the result, because we don't want to get lost. And I don't know how long it's going to take. So let me say that rate times time equals distance. The plane flies at 110 miles an hour. So here's the plane where we're steering the plane. So I'm going to make that 110 times the time. I'll make that lowercase time. And then we've got wind. Wind is at 25 miles an hour, so that's going to be 25t. So that's the distance it is. Now the other thing is we have a 70-degree angle right there. It goes down to here actually. And so if I spread this out, this is 70. This is a straight line, so this is 180 minus 70, or 110. Now this 110 and that 110 just are inconsequential. They just happen to both be there. So let's use the law of cosines. Now, law of cosines works really well when you've got side, angle, side. So I'm going to do that. I'll put this on a side by itself in the law of cosines. So I'm going to call this one C and this one B and this one A, I guess, just to give you some perspective. So we know that C squared is equal to A squared plus B squared minus 2AB cosine of the angle in between, which is the angle C, in our case 110. So I'm going to put 110 squared, 110t, and square that. A is 25t. Have to square that, plus b squared, that one's 500 squared, minus 2 times 25t times 500 times the cosine of 110. So there's the entire law of cosines. Now let me multiply this stuff out and I've already got it done, so I won't waste your time on that. But this one, 110 squared, is 12,100, got t squared. 25t squared is 625t squared. 500 squared is 25 with 4 zeros. Then this 2 times 25 times 500 has a minus from that. So we've got 25 with 3 zeros times t times the cosine of 110. So there's our problem. Now the unknown here is t, and we've got a quadratic formula problem with that because we've got t squared here and here. We've got t to the first here. So let me work it around so that it looks more like a quadratic. I'm going to subtract that from both sides. So if I take 625 minus 12,100, I get minus 11,475 t squared. Now I'm going to put this one next. So minus 25,000 t cosine of 110, and then plus 250,000. So there's our problem. Now if I use the quadratic formula, I get a value for t. Actually, I get 2 of them. So t is equal to minus b, here's b, so I'm going to have 25,000 t, or not t, cosine 110. I just need the coefficients. Cosine 110 is negative, so be aware of that. Plus or minus the square root of this thing squared, so minus 25,000 cosine 110 squared minus 4 times a, which is minus 11,475 times c, 250,000. This is a massive bunch of numbers. And it's divided by 2 times a, which is 2 times minus 11,475. Okay, so I've got to clean up just a little bit here. I got a little bit of that out of the picture, but there's a 25,000 in this thing. So let me kind of show it to you over there. There we go, 250,000, sorry. All right, so let me get some numbers in here with the calculator. And I've actually got some of this done, so let me deal with that. This is 25,000 cosine of 110 plus or minus. Now this one, when it's squared out, the negative goes away. And so I've got that one squared out, and then these double negative right there. Okay, so I did this on my calculator already, and so what I ended up with was, let me see what I ended up with. Yeah, right. Okay, so I've got 107,462.138. Now that's an estimate, of course, but I've got that, and it's divided by this is minus 22,950. Now, this is a negative. We plus or minus the square root and then divide by a negative. So we've got 2 answers, 2 possible answers. So if I take minus or 25,000 cosine 110 plus, and this square root of this thing is, let's see here. Ooh, actually, I gave you the wrong answer. This is with the square root taken. I already took the square root. So there's the square root already taken. So plus or minus 107,462.138 all over minus 22,950. So I will get, if I take the plus version, this will be a negative plus a positive, and so I will have 25,000. Let me get some stuff going here. Okay, so here you go. Let you see this. 25,000 times the cosine of 110. So cosine of 110. Just to show you that it's negative. Okay, so there's that. That's a negative number. And then I'm going to add 107,462. So plus 107,462.138. So there's my numerator. I divide that by minus 22,950. Now, obviously, we don't want a negative number, so that was not the best answer. It's not a logical answer. So we added in here. Let's subtract instead. So I'm going to come up here and use some values I already have. Let me take the first one that I had, which is this. Okay, so let's take that. And then we are going to subtract, so minus 107,462.138. Keep as many decimals as I can till I'm done. So there's that. So that's a very much giant negative number. Now I need to divide by negative 22,950. So a negative divided by negative, and there we go. So we've got the logical time is 5.055, rounding a little bit. So there's our answer. Now, we've got to finish the problem. So I've got to multiply that. That's the time it's going to take. But to get the length of this and the length of this, I've got to multiply my velocity of my plane and my velocity of my wind. So I've got those. Now the other thing is I might want to know how to steer the plane. So if I need to know how to steer the plane, I need an angle. I need to know this angle right in here, because I'm not going to steer the plane all 70 degrees. It's backed up a little bit. So let's deal with some things that have to do with the law of sines. This one, we've got the angle here, and we want the angle here, and we've got this one. All right? So the wind side, I'm going to just write that as the wind side. That's going to be A. That's 25 times T, okay? So is equal to 25 times T, which is approximately, I'll just put it on here, so times 25. So it's about 126.38. 6.38, okay? Now, the C side, so this is A. Now C, what's C? It's 110 times T. So I take 110, here's 110 times, now my time value is up here. So that gives me 556. So about 556.05. Okay, I'm just using 2 decimals, so I've got a little bit of error in there. Now, law of sines. And I'm just going to use a couple pieces. I'm going to use A's and C's. So I'm going to say that the sine of A is to the length of A, which is 126.38, as the sine of C, the C value is 110, is to the length of C, which I've got as 556.05. So there's my estimation. All I have to do is multiply both sides of this by 126.38. So let's get the calculator in here and do that. So we've got sine of 110, sine of 110, multiplied by 126.38, So times 126.38. And again, I've rounded this a little bit. I probably should not to get a really good answer, but this is going to be fairly close. So I've got that. Then I've got to divide by 556.05. So divided by 556.05. And there we go. So that's our sine value of A. So sine of A is about 0.21357, etc. Okay, now I shouldn't keep all these because I was rounding here, so they're not worth much. But let's figure out what the angle is. So let's find the inverse sine. So let's take second sine and come up and pull this number. And that is about 12.33 degrees. So A is approximately 12.33 degrees. Let's just call it 12 degrees. And so we come up here where we had our plane. We said we were aiming at 70, but we would, or we had to land 70 degrees from north and go 70 degrees from north, but we need to aim it 12 degrees less than that. So we should actually aim the plane at 70 minus 12, which is 58. So aim the plane. Aim the plane to a compass rose of 58 degrees. And the wind will do the rest and get you to 70. Okay, so it's going to take 5.05 hours. You're going to aim the plane about 58, and you're going to end up doing a total number of miles. These are air miles, not ground speed or ground distance, but 556.05. So there's a practical application. It actually uses both law of sines and law of cosines.